Hello guys, welcome to Physics TV. I hope you all will be fine. In this video, I'm gonna explain the lesson Projectile Motion by using digital tools, animations, stimulations, and the vast use of Microsoft Whiteboard, past papers to make your lesson very easy, interesting, and fruitful so that you can learn and enjoy each topic as you were doing in face-to-face classes. After watching this complete video, you will be able to describe well about projectile motion, drive its mathematical equations, and do the work problems and past papers very easily. So now let's watch the video. Observe carefully. Just see the motion of an arrow, how it is covering distance horizontally and vertically at the same time in the curved path. This curved path is called a trajectory. Now see free fall motion. With the help of another athlete, just see the trajectory with the fall of a ball. Now just see the students how they are demonstrating the projectile motion in school ground. Dear students, as you have observed the video that when any object or a particle is moving above the plane surface, here this plane surface concept is very important to understand well. As you observed in both the examples that both athletes they were moving on the plane surface, they were standing on the ground means but when the first athlete threw the arrow was moving above the plane surface, not on the ground surface. Same in the second example, the ball was moving above the plane surface, not on the ground surface. So this means that above the plane surface, and not only above the plane surface, but they also gains two other properties that they will must make the curve path and they must have a acute angle, mean angle more than 0 and less than 90 degree. So and in the other examples also we have observed in the on the playground that when they throw the ball you also observe the same thing that the ball was also having the curve path and having the acute angle with the horizontal surface. So such type of motion is called a projectile motion. We can conclude the definition now that it is the motion of an object or particle which is moving above the plane surface in a curved path under the action of force of gravity called projectile motion. Dear students, now it's the time for stimulation activity. Here you will enjoy to observe the projectile motion once again, and at the same time you can see the effect of angle and speed on projectile motion. So pay attention and watch carefully. From this area I can manage the speed. From this area I can manage the angle. I'm going to adjust the angle at 5 degree. Now just see the trajectory of a projectile motion. Now I will increase the angle just to see what is the effect on the trajectory. So as angle has increased, just see the trajectory also has increased. One more example, if I increase more angle from 10 to 20 degree, so it should be also the trajectory should be increased also. Let's watch. Just see. Yes, just see that now also the trajectory has increased. So as we increases the angle, trajectory also increases. Now we see the other aspect. Now I will fix the angle at for example, at 10 degree, and I'm going to adjust the speed. For example, speed is at 10 degree, at 10 meter per second. So at 10 meter per second, see the trajectory. Now when I increase the speed from 10 to 50 meter per second, just see also the trajectory has increased. Again, now I will check rather if I increase the speed, the trajectory is going to increase or not. So when I increase the speed 20, so we observe that the trajectory also has increased. It means we are increasing speed, trajectory also increases. Dear students, I'm sure that you got the basic concept of projectile motion. Now, I would like to give you a quick review of your prior knowledge, which is soundly needed to go deeply into it. So, the first thing is equation of motion. As you know, V is equal to U plus AT, where V final velocity, U initial velocity, A acceleration, T is the time. But this acceleration, at which time it happens? When the object is moving on a plane surface. Plane, plane surface. This plane, it can be the plane of a floor, it can be the plane of a earth, plane of a road, straight road, or a plane of a table, etc. But if we change the nature of a motion, if the object is moving in the upward direction or moving in a downward direction, the straight path, like a free fall motion, or if the object is moving, covering distance horizontally and vertically at the same time as a projectile motion, then this acceleration, it transforms into g. Therefore, this equation, it will be equal to v is equal to u plus gt. Now, the second is the distance of the displacement equation, which is needed. So we know that also s is equal to ut plus half, or also we can mention 0.5 at square. Here s is distance or displacement, depends on the situation, u initial velocity, t is the time, and a acceleration. So when the nature of motion will be changed, as I have discussed before, so it will be transformed into s is equal to ut plus half gt square. Now the second important factor, that we need to understand well the mathematical explanation of the projectile motion, is the resolution of a vector. Resolution of vector, here we know that when we resolve a vector into its components, for example here, if an object is placed on the table or something, and if I exert the force on it at some angle theta, it can be any angle, then what will be happen? The objects will be displaced in this direction, but I am exerting force here in this direction. So let's suppose that my force is 20 Newton. So it means that the only some of the part of that 20 Newton is utilizing to displace that object horizontally. So where the other part is going? So other part is acting in the upward direction. So that's why it means that whenever any force is going to act at any object at acute angle, then this force, this vector resolve, divide, distribute into the two components, and these two components are always perpendicular to one another. So the components which is along x-axis, if this is the f vector, this is the f, then the component along x-axis, it will be fx, mean the horizontal component, and the component along the y-axis, this will be fy, this component. So these components are also called rectangular components. So here we need only the equations for the purpose of projectile motion. If you have any problem still in this topic of resolution of vector, then just wait for my next video on resolution of a vector. So where we need to resolve a vector into two components, or the horizontal components, always it is equal to f cos of theta. What is f over here? This is the constant vector, like over here, this one. which has been resolved into its components. And its magnitude is always given, and this theta, this is the angle which that concerned with this force F it is making with the horizontal, and Fx, x is the subscript. Okay, F is a capital, x is the subscript, so this is the component, x component of a F, means the vector F, here the force F. For example, if I'm talking about the velocity component, velocity x component, so what it will be? It will be v cos of theta. Means that whatever the vector will take, that it will take the shape of that one. If I say the horizontal component of the distance, then it will be what? As x, as subscript x, so it will be equal to what? As cos of theta. Mean the same. If you focus, this is the same, but the components we have the same vector with cos of theta, the same vector with cos of theta, the same with cos of theta. Okay, so in this way, if we take the vertical component, for the vertical component, then just almost similar, just we will take here the, for example, if we're talking about this previous force F, so the vertical component of the F force or the F vector, it will be what? F sine of theta. And if we are using the velocity vector and we need its vertical component, then it will be Vy is equal to V sine of theta. And if we're talking about the distance, the displacement vertical components, then xy vertical component, it will be equal to what? S sine of theta. S sine of theta. Same thing as we have discussed above. So here, same F and F, V with V, S with S. So very simple. You need to keep in mind that we will use very frequently. Okay. After this, just focus on this diagram, and I'm sure that you are well aware about that path, that trajectory of a projectile motion. Means object is covering the distance horizontally and vertically at the same time. For example, say here, till that position it has covered the distance here x and also y distance. Here also it covered x distance and here also same time y. This point, for example, how much x distance has increased and also y distance has increased, and so on so on. Even if I just check over here at that point, then say here what, till here to here x and here to here y. So the means that the object is covering distance horizontally and the vertically at the same time. One thing. The second thing is what? That now we will talk about the velocity. Very important. It need your full concentration of velocity. Okay, so for example, if we injected or throw the objects from here, from the ground in the upward direction with the velocity, initial velocity, suppose u. It can be any, and it's making angle theta with the horizontal axis, x-axis, with this x-axis. Then what will be happen? Or we can say that till here, till the straight line, till that point, its velocity is increases very fastly. But after that, its velocity starts to decreasing, and when it reach at that point at A, then what happens over here? This is very important thing need to understand. Okay, let's see over here. If I make here the rough diagram, like when it's moving upward, it is moving. Okay, and at that point, so after this, it will go in the downward direction. Downward direction means after that it's direction is changing, it's going to be reverse. What does it mean? Why it happens so? Okay, so it's very simple. That it means that here, because at each and every point, if means if I see at that point, we know that sees both the components of the velocity. Here will be the x component, and as it's moving upward, so here will be the y component. If velocity is, we have considered u, so this will be uy, this will be ux. Okay, so means that both the forces are existing, horizontal and the vertical. That's why object is moving upward. Here, for example, same thing, horizontal also exists, vertical also exists. That's why still it is moving upward. Here also same thing. Horizontal exists, vertical exists. But when it reached at that point, after which it will just go down, it will change the direction. Okay, but keep in mind that when it reach at that point, like for example in the free fall motion, we see that when object, we throw the object upward, when it reach at the highest point, then when the velocity becomes zero, then it fall down at the, from the same point. It fall down, actually it fall down on the same point. Okay, it comes down, but we show it from the, to represent it like in the other lines, that's the falling downwards. But it is just, it attains, it gain the same path. uh, this is for going upward, this for the going downward. When the velocity becomes zero. So here little bit same concept is over here. But so if now at that point, at this point, suppose this is point A in this diagram, if here the velocity will become zero, then object must fall down over here. But we see that it's not falling, it is moving ahead. But yes, not in the upward direction, just in the downward direction. So what happened? It means from that point, its vertical component of the velocity, it becomes zero. Because here the vertical components become zero, that's why there will be no motion in the vertical direction. But yes, at the same time, here its horizontal component will exist. Its ux will exist, but its uy, it will be zero. That's why what will be happen? The objects, it will still continue to move, but in the downward direction. Okay, so same thing. So now if we come back, okay, let me repeat this thing once again. Usually students confuse at that point and they make a mistakes over here. Okay, so let's see that I said, okay, that when the object reach at that point, this point A, then what happens here at that point? Object is not falling downward directly. It means that here totally velocity not become to zero as it happens in the free fall. So this is, keep in mind, this is projectile motion, not the free fall motion. So keep this difference in the mind. So what happens over here? Here just the vertical component at the point A, the vertical components, it will be zero, but still the horizontal component, it exists. If we're taking u initial velocity, then also we'll write here the uy. Okay, it becomes zero vertical component, but if the horizontal component still exists, so it will be u cos of theta, like we have discussed before in the resolution of a vector, u cos of theta. Okay, so now it may, I think now you got the concept that what happens at point A. So now come to the main diagram. Okay, see now over here. So what happened at that point? At that point, the velocity will be there ux, but as it also mentioned over here before, that uy here it's zero. Vertical components become zero. And second thing also keep in mind that the vertical, when vertical is becoming zero, when we have the maximum height. Maximum height, or also we can say we have the maximum vertical distance. These concepts we will use later. So keep in mind that where the vertical component zero, at which point, at which destination, at which position on the trajectory during the projectile motion, that when vertical component becomes zero, that point when it has a maximum height, when we have the vertical distance. Okay, then go ahead. For example, if I take this point here also, there are the two components. Okay, which one? Horizontal, but here the vertical, now it's coming downward, so it will be in the downward direction. So here we have the little different options. What the different options? That because now here the velocity direction has changed. Velocity direction is reversed now, is opposite now. It's changed. So when the directions will be changed, that's why what will be happen? Its components also will be changed. Before means from O origin till O, from here to here. What will happen? The vertical component was in the upward direction. Okay, it will be little tilt. At each point, directions will be little changed. Okay, but here now, and ultimately it will be zero at A. But here no, at this point it will be downward, this point downward, this point downwards, this point downward. Means that the direction of the vertical component has reversed, has changed. That's why it will be minus u sine of theta. Minus u sine of theta. So here minus is just indicating you what, that the direction has changed, but it doesn't affect. In the some textbook and in the notes, when you maybe you will see that many people they don't use this minus sign. They just take uy is equal to u sine of theta. So both the option, but the perfect way is you must mention the negative sign. But if there's a no negative sign, okay, then it, I mean, you don't bother about it. Okay, I mean sometimes they take it. Because it's understood that here the, because the direction has changed. Before here it was moving upward from O to A and from A to B. If we resolve, if we divide the velocity component at any point except A, except the highest point, at any point it has the two components, verticals in the downward direction and the horizontal is mean all in the same. So and why there's no change in the sign of a horizontal component? This question comes in the mind. So you can see that horizontal component direction here, direction here, direction here, direction over here, direction over here, direction over here. At each and every place the direction is same. There's no change, no reverse. That's why it remains the positive. So this was the little bit concept regarding to the velocity. It should be always in your mind. So on the behalf of that concept, I can say that now I can discuss about the acceleration. Another very important and tricky thing. Okay, also students confused regarding to the acceleration. Of course here there will be the acceleration of the gravity, g we will use, and let's see that where acceleration exists, and especially the very means the complicated and the tricky things, that at which time we will use minus g, and at which time we will use the plus g. So listen carefully. Okay, so first thing about the acceleration, you know that from where? From the Newton's second law of motion. What it says? Newton's second law says that acceleration produced in any object at which time? When force act on it. Which force? Unbalanced force. So if you have any confusions about the forces, just wait for the my video on the forces. Okay, so here acceleration is the means only produced when there's a force act on the object. For example, if this is the object, if we exert the force, if I'm exerting 0.01 Newton force, 0.01 Newton force, what will be happen? There's a no change, no motion, no displacement. But if I increase the force, for example, 0.15, then it starts to slide. Okay, it means now Now there is a resultant force. I will not go into detail of this one, okay? But what you need to keep in mind that without the action of a force, without the action of a resultant force, there is a no acceleration. Okay, so now on the behalf of these concepts, now if I ask you the question, just think that when this object is moving, okay, suppose it's at that position. For example, this is position C. When it is at that position, suppose this is at the D. When here at A, and here suppose this position is E. Here position is F, and suppose here position is G, and here at the ground state again till the reference level, this is the B. Then where is the acceleration? So it means if I want to check that rather here is the acceleration, which thing I need to observe? I first thing which I need that of course object that rather the force is acting over here or not, or how many forces are acting on the object. So if when we see that the force, because if there's a no force, there is a no acceleration. So which forces are acting at that place when the object is at that positions? At position which position? C. When there's a no air resistance. Suppose that if air resistance is negligible, then there is only one force which is acting right now on the object. That is its weight, force of gravity, mg. Rather we use the word force of gravity, rather we use the word its weight. So it is acting, only weight is acting, force is acting only this in this direction. And if I check over here, force is acting on it or not? Yes, force is acting. Where? Which force? Same force in the downward direction. At this place, force in the downward direction. Here also weight downward. At each and every place where you will check, you will see that the force is acting in the downward direction. So now come back to this from the Newton's law. What in Newton's law says that always acceleration produced in the direction of the force. Okay, if the direction of the force is towards east, acceleration will be to also towards the east. Okay, if the direction of force is towards the north, then all acceleration will be also towards the north. Okay, and if the direction of the force is the downward, then the acceleration will be also downward. So keep in mind, and on the behalf of this thing, now if I ask you, when the object is at this position, suppose C, so what is the acceleration over here? Rather, acceleration is acting where same as for the velocity we have checked along x-axis and the along y-axis, are just only the acceleration acting in the one direction. So what will be your answer? Think. I am sure that you are thinking that because here we have discussed that because force is acting in the downward directions, so it means accelerations will be also in the downward directions. Okay, so and here at that point also means the force of gravity is the downward, so acceleration is the downward, and so on in each and every other positions what acceleration is there. But if I ask you rather when the object is at any position throughout the trajectory at any position, do it has the acceleration horizontally? So what will be your answer? Of course, I think you are thinking right that horizontally there will, as there is a no force horizontally at each and every point, no force horizontally, no force horizontally, no force horizontally, force is only vertically, force is only vertically, force is only vertically at each point. That's why on the behalf of these discussions, I can say what that I can say that the acceleration, what is the acceleration along x-axis and the what is the acceleration along y-axis over here in the diagram. So what is the acceleration along x-axis? think along x-axis. Here we have discussed in detail. So because no force along the x-axis, force is zero. Along x-axis, force is zero. Along x-axis everywhere at each point on the trajectory. That's why always acceleration of the projectile motion along x-axis is zero. And what about the acceleration along y-axis vertically? It exists. And that is what this is g. But here we need to discuss that at which time this will be plus and at which time this will be minus. Now this is our next task, very important task. Again here the students usually they get confused when they're going to take the symbols, that rather at different positions, at the specific positions, the accelerations the acceleration due to gravity we will take positive or negative, because it is totally different from the if from your previous knowledge of the free fall motion. Because in the free fall motion we see we take always when object is moving upward it is negative, when object is falling downwards we take the value of g as positive. But now here the story is different, so that need your concentration. Okay, so let's see. Let me erase it. Okay, so it has it's better if I make it two parts, like case 1 and case 2, for deciding rather the value, the sign with the g, it will be positive or negative in our calculations work. First thing is what, that when this is related to motion of the object which is having projectile motion. Okay, so see, so now when we see here in the diagram that from origin till here just before the point A, what's happening? O to A, the motion is in the upward direction and it is against the force of gravity. It's against the force of gravity. That's mean what will be happen mean 0 to 0 to O. Okay, because it's against the gravity, so it will be minus g. We will use minus sign. Then from here A to B, A to B, and from that point to that point, A to B, before I said O to A, here O to A, that is minus G we have discussed. Now I'm talking about that from O till B, rather we will use the positive sign or the negative sign. So what's happening over here? Here you can see that the motion is reversed. We are talking about the motion. Here motion was positive, here motion is reverse. Okay, so here motion is reverse. So when the motion is reverse, then what will be happen? The motion reverse, that's why means it's the opposite. Therefore we will use the negative sign. So here what will be happen, we'll get the negative sign. So see, look at that stage. I told you that even if I take O to A, it will be negative sign. Why? I gave you the reason. And I also told you that if I'm taking any position from A to B, I will take minus G. Again, same thing, same. Okay, that's why there's a one theory, means that one concept, the case one, that always, okay, always during the projectile motion, whatever the position we will take, the value of G always remains negative. One thing. Again, I'm going to repeat it because then I'm going to go to the second case. Then maybe you will be confused. So please lock it, fix it in your mind that in the case 1, where we just see the motion, that when object is moving in the upward direction from O to, in the diagrams if we say like O to A, what's happening? It is moving its motion against the force of gravity. That's why what's happened, we take the negative, and from O to A, because the motion has becomes what is the opposite, is the reverse. That's why we take the negative sign. So this is the one of the means the theory that always we used to say that take the negative sign of the G whatever the positions in the trajectory Okay, what are the points you're taking throughout the trajectory? The value of g we will take negative. Now, after this, let's see the second case. Dear students, as it's a very important and lengthy topic, therefore the rest part of the projectile motion I will explain in the second video of projectile motion, where I will explain the proper usage of positive and negative sign with g, derivation of its equations in a very simple way, and how to solve the questions from past papers with some important examples. And I am pretty sure that after watching that video, you will be enough good to solve any type of questions from the past papers. Thanks for watching. Please subscribe my channel.